Hello, welcome to today's webinar. Today we'll be talking about technologies that you can connect to Apache Spark. My name is Obi Anamnachi. I'm a developer with Anant Corporation. We primarily work with Cassandra, but we're also interested in technologies that can connect to Cassandra. And this webinar is about technologies that can connect to Apache Spark, which is a technology that can connect to Cassandra. So we're another layer removed. I would ask that if you have questions during the presentation, you save them for once we move to the demo portion. We'll get through the actual presentation pretty quick today, just a couple of slides. Um, but what we're talking about today is notebooks. So technologies that connect to Apache Spark is the theme of this series of webinars in relation specifically to the Databricks platform that we talked about last time. And we're going through some of those companion technologies that are part of the Databricks platform and how we can maybe replicate some of that functionality with base Apache Spark. Today we're talking about notebooks. So the obvious question is, what are notebooks? So notebooks are a web-based interface for editing documents. Usually they are these documents are for specific languages or specific uses. In this case, we're going to be using IPython notebooks, which use the file format IPyNB or IPython notebook. But there's also R Markdown notebooks and other types of notebook files that use different languages. Um, you can take these notebook files and export them to a variety of different formats. If you want a PDF, if you want to export without all of the additional things that notebooks generally make available to you, you can get your source code standalone. So just a normal PY file in the case of IPython notebooks. You can export into raw JSON because that's the file format that underlies most notebook types, as well as HTML. Um, Notebooks are generally made up of cells that can contain different types of data. The main one is code, and it can be run in cells sectioned off that way. But you can also have cells that contain markdown, cells that contain images or data visualizations, and even interactive elements like inputs and sliders. Um, and the reason we're talking about it is because notebooks come pre-integrated with the Databricks platform. In fact, for a variety of languages, but what we're going to be focused on today is Python notebooks with base Apache Spark. So why would we want to use notebooks? Um, so it has a number of advantages. You have easy access to all of your visualizations, whereas if you write Python code in a standard IDE, sometimes you do get access to those visualizations just as easily, but often you do not. Um, it's easy to compartmentalize your code. You can divide it up into cells, which can be run individually, which also gives you the repeatability, which is that individual cells can run the same each time, or they can be tweaked and changed and rerun to tune your results during your development. Um, and also you get access to this meta text, images, markdown, other stuff that you might want to add besides comments that your language natively supports. And then also notebooks are a standard tool for data science, partially because of the repeatability, where individual cells can be tweaked and rerun if you're changing parameters or you're changing even model types and things like that. Um, a lot of data scientists have familiarity with various types of notebooks already. And then notebooks also come with their own various integrations and tools. Like IPython Notebooks has, I think it's called Voila, which can export your notebook to a web page in order to give other people access to your results. All right, that is all for the introduction. We'll be moving on to the demo in a short bit, but if anyone has questions right now, I can take them as I set up the next part of our demo. Okay. no questions right now. So we're going to move very quickly into our demo. So the first thing that we're starting to do is to bring up a Spark cluster. And what we're actually going to do is bring it all up on the host network. What we want is Docker containers, even though we could run both Spark and our notebooks directly on this machine. We're going to Dockerize them because it more closely resembles some type of actual production environment, not fully because we're still on the host network rather than connecting later via SSH tunneling. But that is also something that you can do. And the reason that we're bothering with Docker containers at all is because the way that we get our notebooks to most easily connect to our Spark instance is that we are going to be running the notebook instance through Docker in the same container as our Spark master, using something called find Spark. And the reason we want to do that is because natively, if you're connected to your Spark cluster via notebooks, Spark does not natively run your code in distributed mode. It will run it on a single worker. And this way, we are actually on the same machine as our Spark master, which makes it easy for Find Spark to generate Spark contexts for us, because that's what we're going to be using it for. And then also makes it pretty easy to, if we want to run code in distributed mode, to export a source and then run that via Spark submit. We're not actually going to be doing that today, but that is how you get your full functionality with notebooks in Spark. So we're moving into our container for Spark master, and we are going to make sure to install PySpark. It's going to take a little while. And then we will also install IPython notebooks, which is currently called Jupyter Notebooks. So another thing that we could do here, rather than setting up a notebook to use with Python, is to jump directly into the PySpark shell. Okay, but we're focusing on notebooks today. And this is all something that you could use a Docker Compose file, or write your own Docker file for, or create your own image. All right. We can now move back here. our token. Actually, let's just open straight with the token already included. So when you run Jupyter Notebooks, it generates a token for you, which you will then use to connect. It can be used whether you are actually looking at it from the cluster, which in this case, since we're on network equals host, then all of the container ports are the same as the machine ports, which is insecure. Don't do that in production. But so the way that we're going to connect to make sure that we have a proper Spark context rather than building it from scratch, we're going to use Find Spark, but that's currently not installed. Okay. So starting off, creating our Spark context. Oh wait, I forgot to initialize Find Spark. Okay, now we're creating our Spark context. Quick reminder that if you have questions at any time during this presentation, you can put them in the chat, and I will respond to them as I can when I have time, or at the end when we finish up. So we're starting with a simple application that will basically solve for pi. So what Find Spark is actually doing here when we create a Spark context is that it is looking on whatever machine you're running the code on in some fairly standard locations for Spark to be installed, and then using that to help you create Spark contexts. Whoops, I forgot to import random really quick. Sorry about that. Really should have had this prepared fully in advance. But basically the way this works is that we are going to use the polar coordinates for points on a circle in order to calculate pi. And here's where we start actually using our Spark functionality. So we're using parallelize to turn something into an RDD, and then filter and count. And you can see we have an approximation of pi. And then if we look at the Spark UI, you can actually see some info for some of the jobs that have been run on the cluster. And then we also have a short tutorial that shows that you can load data. Essentially, what we're doing in this next part is we're using the Spark SQL, and first we're going to stop that first Spark context. Is there a doc/wiki page or README file I can follow to run all of this on my local? Not currently. I've taken this from various other articles, but in the blog post released tomorrow, there will be a full accounting. And then I can also publish this notebook if you would prefer. So this time we want data to work with. So what we're actually doing here is we're installing scikit-learn just because it has some data in it that we can work with. It's actually a familiar data set to people who have worked with, who've done some of the basic data science courses previously. We're going to be using the iris data set, which is a classic for various machine learning, and actually something we worked with in my Cassandra and Spark machine learning series, where we imported this data via Cassandra to load it into a Spark context to then work with. And all that information can also be found on the Anant blog as well as the YouTube channel. Actually, we do not need PCA. So step one, get the iris dataset. And a fun fact about the process that we're about to go through after we make another Spark context is that the data types of this data actually matter. What scikit-learn does, because it's heavily integrated with NumPy, is it uses NumPy types. Whoops. And NumPy arrays rather than the standard Python types and arrays. And that clashes with Spark SQL types because those are compatible with the base Python types. So what we're actually going to do here You're still looking at the Spark job page. That is not correct. I've been working on the notebook. Must have pulled it into a separate window by accident. Can you see it now? Okay. So what we're doing is we're using the pandas function that exports to list, a normal list rather than a NumPy array. And this also transforms all of the data types within that NumPy array into standard Python data types. And using parallelize, we've generated an RDD. So we can use take to get some of the data out. And then we can transform this also into a data frame, which makes it compatible with PySpark's MLlib. And therefore, everything that we did in that machine learning with Spark and Cassandra series. And we're going to use some of the other data that's in the Iris dataset. It comes as a bunch, by the way, if you are interested in what data type that is. Whoops. I am forgetting something. Whoop. What is it that I'm forgetting? No, that's the Scala method. Anyway, please bear with me for a little bit while I try to figure this out. I believe that's what's happening. I said that we were going to use Spark SQL, and then we never did. So we need to create what were my instructions for that? create a Spark context that already exists. But what we need to do is to create a Spark session that includes Spark SQL so that we get access to the 2DF method of RDDs. But anyway, as I was saying, now that we have our data in the form of a data frame, we can pick up with all of our machine learning and various other functionality that PySpark provides as detailed in the machine learning with Spark and Cassandra. And I believe that is where this webinar will end for today. So if there are any further questions, again, the resources used today, the full Python notebook, as well as the instructions for bringing up the cluster and installing the various things that we use, will all be in the blog post tomorrow. But if there are any more questions today, we'll have some time for them in chat while we close out. All right, I'm not seeing any extra questions. So if you desire to partner with us, either as a partner working with us or as a client hiring us, feel free to get in touch with the contact info on this last slide. And since there are no questions, have a nice day.